Hi guys, so I'm going to nick through the heart in this sort of a fashion. Now this is a way that I did it for a few students last semester, and it really helped them understand which way the blood flows through the heart, as well as a little bit about contraction principles as well, and the different names of the valves and stuff like that. So we'll nick through it and see if we can't get to the bottom of it. So you can see on the left hand side I've written the right side of the heart, and on the right hand side I've written left side of the heart. So we're looking at this from the anatomical point of view. So we're looking at a heart from sort of face on. You'll see it's like this all the time. Let's turn on the chamber names here. So I've got two boxes for my right side. I've got my right atrium at the top, which is a little bit smaller than my right ventricle, and my right ventricle is in the bottom. Left atrium a little bit smaller. Left ventricle, and you see they're all joined up here, and that's going to help with our blood flow in a minute. So we'll turn the chamber names off because it's going to get a little bit hard to. It's going to get a little bit busy if we leave that on. So okay. So when we first come in with our blood, we're coming from deoxygenated blood from the body, from the systemic system. So give me a second here. What we do is we come in from like our inferior vena cava here and our superior vena cava here, and I might just write that down here. Inferior VC vena cava. So that'll be our superior. Superior vena cava. Okay. So our blood comes down here, and we'll draw a blood drop in a minute. It goes into this chamber here, which is our right atrium. It goes through a valve here and into our right ventricle, where it then comes back out. So let's start here. We've got our blood comes in here, and from the lower side of the body here, from the inferior portion of the body here, and from the superior portion of the body here, it doesn't go through a valve here, it just goes straight into the right atrium. Good. So this is our first sort of spot, our first stop off, the right atrium. From here, we're going to come down and we're going to go through a valve. We put the valves on. We're going to go through a valve and into our right ventricle. You can see the way this valve is made, that if there's more pressure in our atrium than there is in our ventricle, it's going to push the flaps of this valve open. So let's have a look at our valve names over here. So this valve here, we call our tricuspid valve. So this valve has got three little cusps on it, and it's got three chordae tendineae and three papillary muscles. And the idea is that when the pressure is higher in the atrium than it is in the ventricle, the blood will be able to push this tricuspid valve open and travel into the right ventricle. Okay, so we've gone from our superior inferior vena cava to our atrium, we've pushed the valve open, and we've gone into our ventricle. Now what causes the increase in this pressure of the atrium? Well, it's because the atria contracts. So we can see our atria contracts. It's a little bit off because of the other drawing I've done, but we can see that the atria pushes down and reduces in volume, and we know if we reduce in volume, we increase in pressure, so therefore the pressure is going to increase, and it's going to cause the blood to force its way into the ventricle. Good, so we get a bunch of blood filling up in here, in our right ventricle. Now, what we have also is a pulmonary semilunar valve, as written here. So when we have an increase in pressure in our ventricle that is higher than the pressure in our pulmonary artery, which I'm going to draw on now. Artery going up here. Artery away, this vessel is going away from the heart. We have our lungs here. So let's go back to that blood. We're in the ventricle, our right ventricle. We're going to increase the pressure by contracting the ventricle. Let's contract the ventricle and see what it looks like. Okay, so we can see that the ventricle contracts from the bottom and goes superiorly, or goes up. And that causes our decrease in volume, which causes our increase in pressure, which causes our blood to shoot up here and out and into our pulmonary artery. And it's this increase in pressure in our ventricle, which overrides the pressure left in our pulmonary artery and opens this pulmonary semilunar valve. You see, it's like a trapdoor function, so it opens that one up. And because we have so much pressure coming in here, we close off these trapdoors here. Okay, let's just relax that. Relax the ventricle. Good. Okay, so this blood is still deoxygenated at the moment. Remember, it was deoxygenated from the systemic system. It's come through here. It's all deoxygenated, and it comes up to the heart, up to the lungs. Sorry. So we come to the lungs. Beautiful. We trade off some carbon dioxide, and we bring on some oxygen, and we call this function external respiration. Okay. And then when we come out from the lungs, we are now in a vein because we're returning towards the heart. So we're in our pulmonary veins. Pulmonary veins. And we go into this vessel here, which, as we know, is our left atrium. And our left ventricle is underneath. So let's just trace that blood, drop of blood. We've come in here, so we've come in here, and we've come into our left atrium. Now our left atrium starts to fill up with blood. It's all very good. Eventually we get left atrial contraction. It pushes through this valve here, and this valve here has got a slightly different name. It's called a bicuspid valve because it's got two flaps trying to hold it. Sort of a bad drawing there, but two flaps that stop the blood from going through, and this and two sets of both papillary muscles and chordae tendineae. So we push, we have extra pressure in here, which overrides the pressure in the ventricle, and we open up this valve here, and the blood will flow into the ventricle. Okay, we have filling up of blood here, and then what happens is we're in the right ventricle now. It overrides the pressure in the aorta, which we might draw. Okay. So this is our aorta here, and we have this valve here. You can see the way the trapdoors are functioning on here. We have sort of going upwards. So if we get an increase in pressure here, is higher than the pressure in here, the trapdoors will fling open, and our blood can rush into the aorta. So that's basically how we get that to go through there. Let me just, yep. Okay, so, and then once we are down in the aorta, we go out into smaller and smaller arteries, which eventually turn into capillaries, which eventually turn into venules and veins, and then we end up back back into our inferior side, inferior or superior vena cava. Okay, so we'll go through that once more. We get blood, deoxygenated blood, into our inferior and superior vena cava. It goes into our right atrium. It compresses and goes into our right ventricle. Then our ventricle compresses, and the blood goes into our pulmonary artery. It goes into our lungs, where we dump off as much carbon dioxide as we can and bring up a bunch of oxygen. It then transfers across through our pulmonary vein into our left atrium. The left atrium will contract, pushing as much blood as it can into the left ventricle. The left ventricle will then contract, pushing as much blood as it can into our aorta. And then we have the repeat. So we have it go back through. It dumps off a bunch of oxygen into the cells or into the extracellular space. It brings up a bunch, takes up a lot of carbon dioxide, and that process itself is called internal respiration, where we are dumping off the oxygen and we're bringing out the carbon dioxide, and then we repeat back up again. Okay, so that is sort of my schematical view a little bit more laid out than an anatomical view of the heart.